now we come to the last portion of Module 2, where we are going to explore various aspects of pH and measure the pH of the Green River sample spots. And so very similar to other probes that we have used, and almost the exact same process as I used for conductivity, I need to calibrate my pH probe. The pH probe looks very similar to the conductivity probe. I'll pull it out here, you can see it. It's pretty similar. We dunk this right down in, that will gather our pH data for us. One of the big differences is that pH probes, due to their makeup and their sensitivity, have to be stored in an electrolyte solution. And so that's what this is. During the course of this experiment, as I am not using the probe, I'm going to go ahead and just leave it in the beaker, and that's fine. But if I was to ever leave this out for more than, say, 10 minutes or so, I would always want to stick it back into the electrolyte solution, and we always keep them stored this way. And so, just like we've done before, I'm just going to rinse off the probe, and actually I should have filled up my distilled water. I'll be right back. And now we are ready to go. So just as I've done before, I'm going to calibrate the pH probe. Calibrate pH. And in order to calibrate the probe, I'm using two different buffers. I'm using pH 4 buffer first. That's something that you always want to note in your notebooks when we calibrate anything, is what standards that we used. So I'm using the pH 4 first. Always rinsing off the probe in between every use. Next, I'm using the pH 7 buffer. Now that my calibration is done, again, I just like to test it and make sure that it does seem accurate. And the software is measuring the pH 7 buffer at 7.08, so that's pretty good. Now I'm just going to test and make sure that the pH 4 buffer is reading accurately as well. And again, that's just to make sure that we are properly calibrated. And this is measuring at 4.07. Perfect. And so we're going to start just by measuring the pH of a few different sort of household and various solutions, just to get an idea for pH range and to get an idea for what types of different household solutions have different pHs. So the first thing that I'm going to do is just tap water. And so this is just a sample of tap water coming right out of our tap here in the lab. And pH does take a little bit longer to stabilize sometimes, so the 3 readings on each will take a little bit longer than they did for conductivity. Sometimes we have to stir things up a little bit here even. In order for our pH to stabilize, and it does take it a little while sometimes. That's why we always keep things capped. our first reading for the tap water, 6.13. Stabilizes a little bit faster for the later readings, 6.25. Our last reading for the tap water, is 6.17. So I think you get the idea. You saw me take all those conductivity readings, and you saw me now take the readings for the tap water. I'm going to continue to take all the readings, but rather than make you watch me take them all, because it's all the same exact thing, and in fact you can do this in lab notebooks, the way that I take the pH readings of all the rest of the solutions, I'm going to be taking pH readings of some Shasta Cola, some toilet bowl cleaner, some bleach, and an HCl solution. And then I'm also going to take pH readings of Green River samples 1 through 5. But rather than make you watch through all those, what you can write in your lab notebooks at this point is that the pH readings of all of those different things, the cola, toilet bowl cleaner, bleach, HCl, and Green River sample spots 1 through 5, those pH readings were all taken in the exact same way that the tap water was taken. And that's always a perfectly acceptable thing to write in your lab notebooks. If you're repeating procedures identically just for different samples, you don't have to necessarily log all the steps for each different sample that you do. You can simply record all other samples were measured in the same way. And that's always a very acceptable thing to write in your lab notebooks. And so feel free to write that in there as your procedure for pH, and all of that data will be provided for you in the spreadsheet. Let's just take a look at our conductivity sample here. Oh, and that is nicely clear. So I will get that last measurement while you are still on camera. Let me flip back to that in my notebook so I'm all ready to take my recordings or take my measurements down. So just to give you an idea, again, this was from the conductivity before, but remember how cloudy that was. This is why we allowed it to settle. So now it's fairly clear, and we can see all that white precipitate that has settled down to the bottom of the beaker. And so now we're just going to get those conductivity measurements now that that precipitate has settled out. Try to do this without stirring it or mixing it up too much. Conductivity reading 1 for the mixture of calcium chloride and sodium carbonate is 3,160. Conductivity measurement 2, 3,070. And conductivity measurement 3, 2,990. And so again, that was for our conductivity, the mixture of calcium chloride and sodium carbonate. And so I'm going to go ahead and stop the video now, but I will gather the rest of my pH readings, again, in the exact same way that I measured the pH of tap water. For the portion of this experiment that does have you performing a bit of a titration, so to speak, let's see what part that is. On page 56 of your manual. And so module 2, task 2, part 2, investigation of the effect of a buffer. For that portion of the experiment, we're actually going to just supply you with the graphs. I'm not going to take the data here. I have previously acquired data that I will use, and you don't have to graph those as part of your post-lab. And so when you look on your post-lab requirements for this part, and we'll talk about this in pre-lab, and your instructor will hopefully talk about this in pre-lab as well. But when you are looking at page 67, number 2 in the graphing, the 2B and C, 2B and 2C, generate your scatter plots of pH versus volume. Both of those scatter plots will be provided for you. And so you don't have to worry about graphing those, and we're not going to worry about collecting that data. We're just going to supply you with those graphs so you can just visually see what the effect is of a buffer on pH additions and the effect of buffer on pH change. And so that is all for the pH portion of Module 2. You should have enough to complete all of your post-lab materials. I'll see you again for Module 3.